Hello, we're doing checkpoint 2.19 from section 2.3. They want us to use a squeeze theorem to figure out the limit as x approaches 0 of x squared times sine 1 over x. Now, I don't know if you've ever seen the graph of sine 1 over x, but as x goes to 0, we have sine of something that goes off to infinity and goes really fast, and we know that sine oscillates. So imagine that oscillating forever, being squished around 0. So there's some weird things that happen there. If we didn't have the x squared there, it would be undefined. But the x squared is kind of giving it the amplitude, and the x squared, kind of goes down to 0. So I would encourage you to draw the graph of this, or put it in Desmos or somewhere. But let's try to do this analytically. We know that the sine function, regardless of what we put into the sine, the argument in there, is always going to be between -1 and +1. So that's our starting point for the squeeze theorem problems. And what we're going to do is we're going to multiply by x squared on, instead of saying both sides, there's actually 3 sides to this. So let's multiply everything by x squared. So we have a negative x squared, and we have an x squared times a sine 1 over x, and we have an x squared. And so x squared is always positive, so we don't have to worry about switching signs or anything strange like that. And also, we know the behavior of these two functions. We know the behavior of negative x squared. So negative x squared is an upside down parabola, and we see as it gets closer and closer to 0, it's going to be 0. The positive x squared, we know the behavior of that as well, and that's the right side up parabola, again going to 0. And so we'll make a note of that the limit as x approaches 0 of negative x squared is equal to 0, and also that the limit as x approaches 0 of positive x squared is 0. So whatever is happening here has to be essentially squeezed between these two functions. And since they're both going to 0, then this function in the middle has no choice but to go to 0 because it's all in between. So then that's what we can conclude. We can say that the limit as x approaches 0 of the original function that we're looking for is going to equal to, because of the squeeze theorem, it's going to be squeezed between those two functions. All right, I hope that helps.